All right, second method, combination or otherwise known as elimination technique or the multiplication addition technique. When you buy a combo, you're adding things to your main meal. You're getting a soda and fries with the hamburger. So that's what we're going to do. We're going to add equations together. We're going to combine them. This is what it's based on. If I have an equation, for example, 3 plus 1 is 4, and I have another equation, 5 plus 2 is 7, watch what happens when I add the two equations together. 8 plus 3 equals 11. Is it true? Yeah, sure is. So we can take two equations, add them together, and you get a third equation that's true. Again, we want to think smart, not hard on these. You want to pick out the easiest variable to eliminate when you add the two equations together. Now, I admit A is rigged for you already. If I add these two equations together, which variable drops out right away? The y, yeah, because we've got what kind of terms here? A 3y and a negative 3y, which are what? Yeah, they're opposites. So when you add them together, they zero out. So the variable y cancels simply by adding both equations as is. So this one's rigged. 16x is equal to 32. X is 2. Once you get a concrete number, you substitute into either equation. Notice this doesn't have that easy equation that we can substitute into, like with the substitution, the revised equation. You need to substitute in either the top or the bottom, and you want to go which one, top or bottom? Top, let's do it. 7x plus 3y equals 17. X is 2. See, that's substitution. We're taking the x out, putting 2 in its place. Subtract 14 from both sides. 3y equals 3, and y equals 1. And as you said before, this is an ordered pair. 2, 1. See if it works. 14 plus 3 is 17, and 18 minus 3 is 15. They both work, and we're happy. Notice the second one. Hey, we got to do a little work on this one. Does anything drop out when you add them together? We need to multiply at least one of these by something in order to eliminate one of the variables. What I do is I determine what the LCM is. Lowest common multiple of x is what in this case? 8, and LCM of y? 6. You going to be better off eliminating the x's or the y's? Yeah, yx. Yeah, you don't have to change the signs. You have the addition and the subtraction, the positive and the negative, built right into the equations. So all you have to do is add them together, and then the x is going to drop out. But what do we have to multiply the bottom by? 4. There you go. Negative 8x. So we decide on this one here. Negative 8x plus 12y equals 52. Add those together, the x's drop out. So this 14y equals 56, and y equals 4. Once you get y equals 4, you can substitute this into either equation. Top or bottom, which one? Top one, all right. 8x plus 2y is equal to 4. Substitute that y in, which is a 4. Subtract 8 from both sides. 8x equals negative 4. X equals negative 1/2. And the solution is negative 1/2, 4, but we need to check it first. And when you substitute these values in, both these equations are true. So we have a solution. It's a point of intersection. The lines intersect at one point. And now for the grand finale, what's the lowest common multiple of x? 15, and y? 12. Think smart, not hard. Which one do you want to eliminate? X or y? Yeah, let's take the y's off because you already have built in what? Yeah, you have opposite signs here. So you might as well go with this one. Now, a second benefit is 12 is smaller than 15, but that's not the main reason. You can get rid of the x's if you want, but then you have to multiply either the top one or the bottom one by what kind of a number? A negative, yeah. And why go to the hassle of having to change all three signs, multiplying through by negative. So let's go with the 12. You're going to multiply the top by what? 3 and the bottom by 4. See, no negatives, just 3 and 4. Zeros out. Okay, you can substitute this top or bottom. I'll go with the bottom here. 5x minus 3y equals 7. Substitute that 2 in for x. Subtract 10. And our solution is 2, 1. Check the 2, 1 in both equations. Make sure it works. And it does.